Welcome to Get Your FRQ On. In this tutorial, I'm going to show you how to use your graphing calculator to find the area of a region bounded between two curves. This skill can be extended to two curves that intersect somewhere, volume of revolution, cross-section volumes, that kind of thing. Really, this is about getting your calculator to calculate something that's a little bit more than just a basic definite integral. So just so we're clear, I have these functions already set up in my y=editor. And to show you what the graphs look like, the quadratic function is in blue, the linear function is in red. For this region, we're talking about the region bounded above by my quadratic function and below by my linear function, so this region right up in here. And to do this, I'm going to go back to y equals. And since I already have these two functions entered separately, typically what's going to end up happening here is I have to come up with a function which is expressed in terms of the other two functions. The area of that region is going to be an integral involving distances between the two graphs. So a fairly easy way to do that is to actually create a third function. Right? My quadratic function is above, so that's going to be my first function. My linear function is below, that's going to be my second function. And so what I'm going to do is I'm just going to go to variables, head on over to y variables, function 1, and then from that I'm just going to subtract function 2. All right, and so what this does is this gives me function y3 that gives me exactly the distance that I want. And then I'm just going to quit out of here, so second quit, and then I'm going to have my calculator do this integration for me. Math 9 gets me an integral, and I want to go from 0, and I think it's to 3 where they intersect, and instead of doing like y2 minus y1 or y1 minus y2, I'm just going to go, I want function 3. Integrating with respect to x, click enter, and we get an area of 4.5. Right, so you can see how this would extend to volumes of revolution. If we go back to y, we can define a radius function, big R of x, little r of x, set up another function that is the difference of their squares, take pi times that integral. If you have a function that gives you cross-sectional area, you can just define that in y equals and integrate that. So being able to understand how to set up integrals for volumes and areas is a pretty big skill on the AP Calculus exam.